This time around, we're going to focus on a technique for recording with multiple microphones in a manner that helps to reduce potential phase problems, and that is following the 3-to-1 rule. So let's go ahead and bring up the PowerPoint and check it out. Okay, 3-to-1 rule. This is about basic microphone placement with more than one microphone involved. First thing up, I want to highlight what is the 3-to-1 about. Well, first is it's trying to make sure we have the best quality sound using multiple microphones. And the basic idea is that when we have two microphones, the second microphone has to be 3 times the distance of the first microphone to its source. So in this particular image that we're seeing right here, we've got this singer whose voice is going to hit this microphone relatively quickly. But that singer's voice could also be picked up by this microphone. If we have this microphone up closer, then what would happen is the sound would get to this microphone shortly after this one, and the volume is going to be loud enough that we could get some phase problems. And remember what we get when we have phase problems, right? If the sounds are in sync, we get constructive interference, where we get a boosting in the amplitude. If we are out of sync, on their way to being perfectly out of sync, and that means when the peak of one signal is equal or happening at the same time as the valley of another, and so that would be the peak reaching microphone 1 at the same time the valley is reaching microphone 2, then we can have some cancellation problems. And so that was destructive interference. So this particular rule is helping us to minimize that. And all we're really doing is making sure that the second microphone is far enough away that the level of, say, this woman's voice getting to the microphone is going to be much louder than the level of her voice when it gets to this microphone. And so any potential impact of phase is going to be minimized or, pretty much just having no implications for the sound recording. Here's a quick look at it again. This is showing it in relation to feet, right? If we have 2 trumpets, okay, one microphone for the first trumpet and it's 1 foot away, the next microphone that we put on a trumpet should be 3 feet away. If this microphone was 1 inch away from that trumpet, then this microphone could be 3 inches away from the other microphone, right? So it's a 3-to-1 ratio in terms of relationship with spacing. The graphs at the bottom of this show what would happen if you have the 3-to-1 rule in place. That means you really don't see any negative effects. But when you don't have it in place, you get something that's called comb filtering. Now, I've got a video posted here so that you can actually hear at the end of it what that comb filtering sounds like when you have a microphone that's out of phase and in phase, and it's moving back and forth in and out of phase, and you'll hear the sound. So check out that video as well. One more spot check on this. How do we avoid the phase problems? Of course, we want to avoid them with the 3-to-1 rule. And one of the things to keep in mind is that sometimes we're tempted to put more microphones on, say, a chorus. We put out more microphones. We want to say, oh, we want to pick up everybody's voice. But to keep in mind that the more microphones we have, the more likely it is that we're going to have phase problems. And that is actually going to make the sound a lot worse. So let's simplify and keep proper distancing and spacing with those microphones to get a much better overall recording. Here's a great example of how just in basic work, even in television, we have to be concerned about phase problems. Take a look at this image. This is an image, a capture from one of our shows here at UCF that is not being produced now, but was a popular one a short while ago. And we've got 3 folks sitting at a desk. We've got 3 microphones. This one, presumably for this guy, this one for this guy, and this one for this guy. So the question is it likely that we might get some phase problems if we're using those microphones? And I would say I would listen for that because there's great potential. Think about the distance for this guy's voice his voice is going to come out. It's going to be picked up by this mic, but it's also going to be picked up by this mic. And the distance between these here are about the same. So it's very possible that his voice is going to get to these two microphones at about the same time, which means there's a good chance that there could be some phase cancellation going on there, and that's a problem. What about this guy? His voice could be picked up by this mic and that mic, and the distance between these is not very far, so that these could interfere with each other with phase issues. So if we were to follow 3-to-1 rule, we would want to make sure that this microphone, if this was 1 foot away from this guy's mouth, then this one would be 3 feet away from this microphone. So the middle one would be 3 feet over, somewhere probably in front of that laptop there, right? So that's the best way to create a situation where you can minimize the phase problems.